All right, everyone, let's get started with the last lecture of the semester. What is it in this format? All right, whatever. So today's topic will be story generation. I will try, as usual, to end early and probably fail, but it depends on how many questions you all ask. Before we get started, so your exams grades were released. The regrade requests are open until next Tuesday. So if you think that someone made an error, you should submit your regrade request before then, or it won't be considered. We've already dealt with a large number of them so far. And just for future, if you're considering submitting a regrade request and you are one of the people who wrote like 10 possible answers for one problem and you're like, why didn't you consider solution 7, which has had several, we've got so many of these requests. We tried to only consider the first answer written. So if you ended up getting points for an answer, like if you wrote multiple answers and got points, you should consider yourself lucky. Do not submit regrade requests in these cases. All right, and other stuff. So final project should be hopefully wrapping up at this point. Should be transitioning to writing your reports and making sure you get those submitted. Any questions? Okay. I see no questions on here either. Oh, okay, whatever. So today's task is story generation. So it's a bit of a departure from the other generation tasks that we've considered, although we have looked at story generation in the form of, in the context of evaluation, when we talked about all the different ways to evaluate using humans and how that is difficult for story generation. Let alone any automatic evaluations. So the task is defined as you're given some sort of input prompt or context, and you're asked to produce a narrative that is inspired by or somehow relates to that prompt. So there's actually a subreddit called Writing Prompts, which we also discussed earlier in the semester, that has hundreds of thousands of these prompt response pairs. This is one of them. Flowers have become so rare that they're the most sought-after items in the world, sold at high prices in black markets. You just stumbled across a natural rose. So this is one of the examples from the writing prompts data set, and you had like 10 different people write stories in response to this. This was the highest upvoted story. It was the color of a sunset, blah, blah, blah. I mean, it looks like a nice story. And if you actually kind of zoom out and analyze the different components, you can see that it actually includes a lot of the necessary or common elements, at least, of a story, right? It starts out by describing some setting. You have this like desert-like environment where it's very rare to have plants even growing. Then a main character is introduced. This is also a first-person narrator for the rest of the story. There's some more setting and more characters introduced. And then finally, there's some new concept that's introduced, this biodome. And once you read this, you probably realize this is some sort of sci-fi-ish story. You probably want to know what a biodome is and what that entails and so on. So these are like all things that would be part of a real story that you would read. All very common properties. If you put this into GPT-2, you get, we have to be prepared and take care of the plants. So it's kind of like a flower selling flowers advice. Here are some links you can click. These are not real links. I just made up these links. I made these slides a while back before GPT-3 access was released. So I wanted to see what would happen with GPT-3. So I played around with it a little, but we can see some completions as well. I don't know if you can see this. Is that visible back there? All right, let's see. Okay, this is quite interesting. Flowers are a tool of the devil. If we destroy all the roses, there will be... I think this one is actually a little better. It tried to and remember, like, we are just using this as a language model. We didn't even tell it to write a story in response to this prompt. Actually, maybe we can do that. Yeah. Maybe I'll do that. So I'll put something like prompt. Or maybe I'll put it in all caps. I am not a good prompt engineer. All right, retry this. Wow. A group of scientists discover a method of producing artificial roses. To unveil the artificial rose. The press conference is... The artificial rose begins to sing and dance. All right, that is... they will soon be selling them. The crowd is so overwhelmed with excitement that they begin to riot. Oh, look at this. It made a new category. How did the artificial rose change? That's actually like a legitimate question to ask about. Okay, that was way better than I expected. Okay, so anyway, what are we doing here? Okay, so GPT-3 is clearly better at this than GPT-2. Another indication of the power of scaling these models. But overall, this is a very hard task, right? So one thing that makes it hard, we discussed in the context of evaluation, but also for training a story generation model, is that in something like writing in the writing prompt subreddit, you might have one or just a few examples of stories that follow from a particular prompt. But there's infinitely many possible stories that could result from any one prompt, right? There's several decisions, even in the prompt that we saw, that you could make to lead the story in one direction or the other. There's so many different choices you could make. All of them are equally acceptable. And we only observe one or a very few examples out of this huge space of acceptable stories. So when we're training our model with maximum likelihood, we're essentially saying put all your probability on this one observed story and put no probability on other potential stories that you just don't have in your data set at all. This makes both training and evaluation difficult. The other thing is, how do humans write stories, right? Many of them may write stories left to right without any sort of outline explicitly constructed, but in our minds, we probably know or have a general idea of, okay, here's the scene I'm trying to write. Now let me translate that into words. Here's the development of the character that I want to convey, or this is the purpose of this metaphor, and so on. It's very unclear what these language models are doing when they're confronted by this task, right? They're, trained to produce the next word that was in their data set. Now we port it over to this story generation setting. They're not explicitly doing any sort of high-level planning that we can interpret, at least. Other challenges, stories are really long, so we talked a lot about those like long-range transformers and how there's many different variants of those things, but it's not clear if any of them actually work or not, and what kind of information they need to extract from the long-term context to actually, that's actually useful when generating the next word. And finally, stories, unlike a lot of other data, like maybe news articles or parliamentary proceedings, they have all sorts of complex, like literary phenomena, like things like metaphors or long character arcs and narrative elements and so on that you wouldn't find elsewhere. That said, that none of these challenges has prevented people from working on story generation in the NLP community. It is a task where there's a lot of data available, and it's also an interesting task, right? Because in part of all of these challenges. So we'll look at the two of the modeling decisions in more detail, but generally speaking, one easy way to perform this task is just to fine-tune some language model on a data set of stories, right? So I could take GPT-2 and fine-tune it on this writing prompt subreddit, and it'll probably give me some, like, at least at the surface level, text that looks relevant to the prompt. Whether it'll give me an enjoyable story or not is more arguable. I would say that that GPT-3 story, although kind of weird in parts, was just like mildly enjoyable, especially these discussion questions. Like, this could just automate a whole creative writing class, maybe, if it could generate questions like this. I'm just kidding. Of course, it can't do that. But yeah, so of course, I could just fine-tune some language model on this task, but as we mentioned before, that's not taking into account this kind of more abstract planning process. So a lot of the work in story generation focuses specifically on first getting like a higher level structure or outline for the story, and then kind of filling in that outline with actual text. So it's a two-stage process. This is probably the most popular type of setting, other than just naively fine-tuning your language model on story. So one of the first approaches in this vein was called the plan and write approach. And again, I'm talking here only about neural story generation models. There has been a lot of work before the advent of neural language models on story generation that is more reliant on rules and templates and things like that, where they explicitly model the planning process through a series of rules, like, you know, if this event happens, this character will feel this way, and so only these types of sentences can be produced, stuff like that. Of course, these systems are all highly limited in the types of stories they can generate and the varieties of stories that they can generate. They're usually constrained by the templates and rules that you provide them. Oftentimes you have templates like, you know, character X did action Y to character Z, right? And so it's not like you can generate free-form text with most of these systems, the older systems. So in theory, these neural language models can generate whatever text they want, but actually constraining them to follow some sort of outline is a little non-trivial. So in this plan and write approach, there's this two-stage process where you're given the title of a story. So this work looked at very, very simple short stories. They're 5 sentences long, each story. And given this title, they would first train a model to produce something like this, a sequence of words that are kind of they form a storyline. If you just look at these, Carrie is a character, she had a bike, I guess she used the bike to sneak or something like that, and then she got nervous and maybe broke her leg. Or, I don't know. There's many possible stories you could formulate using these words. And the outline here is just, for every sentence, there's one keyword that's extracted, and that is used to structure the overall story. So then, given this storyline, you could train a model to, given the title and the storyline, produce a sentence. And so here you might have a constraint that each sentence should include one of the words in the storyline. And maybe in this approach, producing the storyline is actually feasible because, you know, you can, well, by feasible, I mean, when you produce a storyline, you can have more thought put into the long-term nature of the storyline, rather than when you're actually generating the words of the story, you're more focused on the local, how these two words fit together syntactically and so on, which might not be exactly relevant to the meaning of the story or the narrative progression. But this is, of course, very simple. And to train this model, they have this data set of stories. They have a simple keyword extraction model that they apply over each of the sentences. They use that to extract these words, which form a storyline. Then you can just fine-tune some language model on these two things to produce this thing. So as opposed to, given just the title, generate this story, now you have two inputs. So you're trying to basically add some constraints into the model that shape the story that it generates. So that was a little simple. There's a more complex approach that relies on semantic role labeling to produce this plan of the story. But it's still a two-stage approach. So this paper came out in ACL 2019. It's by some Facebook researchers. So here's a prompt. You're a werewolf. You begin to transform, but instead of a terrifying beast, you turn into a small puppy. And so from this prompt, you first train a model to produce a sequence of these semantic role label triples here. So you have, for each sentence, a verb and the arguments. So like, what is being opened, the eyes here. And here you can have another sentence. So, okay, you've opened your eyes. What's the next verb? Okay, you're gonna use your eyes to look at something. What's the next verb? Oh, you looked and you found something, and then so on. So this is heavily reliant on verbs to define the outline of the story, but also the arguments of each verb, right? Like was, what was, the hunger was gone, essentially, was the meaning of this. But you can see that not every single word in the story occurs in this plan right here, right? And also interesting are these placeholder tokens. So entity 0, entity 1, these could correspond to different characters, or they could be different entities or objects in the story. So here, entity 1, if you look at the actual text, entity 0 open, entity 0 eyes. So this, in the ground truth, is I opened my eyes. So these are like referential to each other. Looking to my razor sharp claws, I found that they were now neatly clipped. Oh, this is an interesting story. But anyway, the overall methodology here is first, given a prompt, produce a plan of the story that is not a complete story itself, but has this outline kind of. And then from the outline and the prompt, generate the actual text of the story. So the actual pieces of these methods, right? How do you go from this prompt to this plan? That can be done by fine-tuning a language model on some data that you extract. And then how do you go from these two things to this full story? The same way, right? You fine-tune a language model and generate the. So I think in their case, they actually generate this entity anonymized story and then have a post-processing step to fill in the entities later on. But yeah, so you can see that in both of the cases here, the plan is extracted from actual data using automatic methods. In this case, it was keyword extraction. Here, it was using semantic role labeling. But the granularity of the plan is actually quite fine-grained in both cases. So in both cases, here you have a keyword for every sentence. Here you have more than a keyword. You have a main verb of each sentence and the arguments of those verbs. So you could argue that for generating a long story, both of these are much too fine-grained of a plan, right? And what you might consider as an alternative is, what if you just had a summary of the story? And from the summary and maybe a prompt, you can generate the full text, or maybe here are the key events that need to be mentioned in the story, or something like this. But of course, due to the length limitations of all of our models, it's very hard to experiment with like large-scale story generation. So that's kind of a blocking factor for current research. All right, do you have any questions? Oh. Could we train the models on story structures instead of specific examples of stories like the hero's journey? Yeah, so I think we'll talk about something like this a little later on, but you have to pair this kind of structure with a more specific prompt. Otherwise, there are many possible stories you could generate given just the hero's journey, right? The more constrained your prompt can be, the more likely it is that you'll generate something that at least adheres to that prompt and is, I mean, the goal of the prompt, the goal of the plan is to prevent the story from veering off into weird directions and becoming irrelevant regarding the prompt. And we know that these language models, especially as we sample more and more tokens, they tend to start diverging from whatever was generated previously and whatever the prompt might be. All of these kind of plan-based approaches are intended to keep the model on track when it's generating the text of the story. All right, so other questions?
I guess in nature of like keeping the story on track, is there any like approaches that you might be generating text and I don't know, you could put like a detection on each word, and if you detect that you came up with a new character, you like store it off to the side so that you can maybe like condition on that to make sure that next time you refer to someone doing something, you don't just make up a new character.
Yeah, so this is a great point. The question is, if your model is generating like new character names or other things that are obviously not part of the current story, and perhaps, I mean, some of the time this is good, right? Maybe you want to introduce a new object or character, but if it's happening too often, it's unlikely to be, actually good for the story. So perhaps you could use some sort of constrained decoding to prevent this, or only allow it every so often. So we have noticed this behavior, especially of producing new character names in many story generation systems, especially as you generate more and more words. I'm not sure, so there are obviously simple things you can do, like maybe constrained decoding, but I don't know if people have looked more closely at other sorts of techniques that you could do, such as, you say, storing something and then maybe it's not appropriate to produce it at this time, but you could keep it around for some future plot point or something. I don't know. Yeah, but that's a great point. All right, let's continue then. So we looked at some different approaches. There's a lot of story-like data available on the web, and unfortunately there's not one single great source of stories that everyone in the community has sort of gathered around. So we've talked primarily about this writing prompts data set up till now, but this method was done over a data set called Rock Stories. So this was the 5-sentence stories. They were written by Amazon Mechanical Turk workers. So you can imagine the incentives for those workers to write actually good, entertaining stories versus just writing the most stories they can in some period of time so they can maximize their payment. Probably going to pick the latter option, right? And finally, there's some other data sets on like movie summaries that people have used. So we talked about human evaluation of stories, story generation models earlier on in the semester. And we kind of discounted automatic evaluations because there's just no reliable way of evaluating some open-ended text generation problem like this with automatic methods. I think the best thing that we have currently is if you have a neural language model that you've used to implement your story generation system, you can measure the perplexity of ground truth stories. So like if you have multiple different language models that you've trained for story generation on the same data set, you can measure how much probability does each one give to held out ground truth stories. And you would hope that a better model assigns higher probability to a human written story than some worse off model. But this doesn't tell you that much, right? You don't know why the model assigned high probability to this story over this other model. There are many more fine-grained questions that we probably want to ask about the generated stories. So if you have a prompt, right, you probably want to know, first of all, did the story that was generated follow the prompt? Is it related in some way? Is it, checking all the boxes that were asked for it from the prompt? Secondly, you might want to look at the coherence of the story. Right, so this is true not just for story generation, but for basically every sort of long-form text generation task. The coherence is how well do the sentences that have been generated fit together. So this is different than grammaticality, where you're mostly looking at it on the sentence level. Coherence is like the logical flow of multiple sentences together. So, like the ETS, Educational Testing Service, has, when you take the GRE and have to write an essay or something, they have researchers studying automatic essay grading methods, and they're highly focused on the coherence of your, right? They give you a prompt, but you can be like loosely inspired from that prompt to write something. You're probably going to write something grammatical, but they might be most interested in, can you logically structure the information that you're conveying so it's easy to understand and gets the job done in conveying that information. So they actually sometimes publish papers at NLP conferences on, okay, we managed to improve this automatic coherence evaluation. That said, they're not grading your essays automatically, right? Because they haven't found anything that works yet. Maybe. Do you have a question? Oh, that's a question. I mean, I actually don't know. Maybe they've started grading your essays automatically. In which case, it would be fun to create like adversarially written essays that are like ungrammatical but maximize the. Okay, anyway. So other types of aspects that are more specific to the types of outputs of these models are repetition. So we saw when we're using, for example, greedy decoding, that language models tend to repeat themselves over and over again. And this is common even if you're using like sampling-based decoding. At some point, your model will start to repeat itself. So you might want to measure that. This seems easier to measure, right? You can look at n-gram overlap of subsequent sentences or something like this. You can also look at syntactic complexity of the sentences. So maybe you have a hypothesis that neural language models will generate simpler sentences than actual human authors, and you can validate this by applying parsers to your data and seeing if there's a distribution shift between generated text and human text. A key element of a story is that it's not completely predictable, right? There should be something, maybe not always, but there should be something unexpected or some sort of mystery that you shouldn't be able to predict every single plot point. So perhaps you can use some entropy-based measures for this. And finally, you might want to evaluate overall enjoyability, right? Which is extremely subjective. If you had, for example, a model that was trained on writing prompts and also posted its generated stories to new prompts on Reddit, then perhaps you could use upvotes as a signal for how enjoyable to that community the story was. I don't think anyone has actually done that. It would be pretty cool, but maybe violates the subreddit's rules or whatever. This paper, which details a bunch of different methods for automatic evaluation of each of these kinds of questions, generally concludes that human evaluation is the only way you should evaluate the quality of generated stories. So we talked earlier in the semester about how human evaluation is also extremely hard to do properly. So the evaluation problem is one of the biggest challenges of any sort of open-ended text generation task. And so if we're looking specifically at human evaluations, we already talked about the Likert scale-based ones, right? So given this story and this prompt, rate how relevant the story is to the prompt on a scale of 1 to 5, or rate how coherent it is, or how grammatical it is. If you have these kinds of stories and prompts, you can also do other evaluations. So in the hierarchical neural story generation paper, I think the one that introduced the writing prompts data set, they use this human evaluation. So given 3 prompts and 3 generated stories, and shuffle them so you don't know which story corresponds to which prompt, can you ask some mechanical Turkers to match up which story goes to which prompt? So what does this actually evaluate? Is this a good evaluation? Yeah, so this is evaluating the relevance of the story to the prompt. Do you think it's a good evaluation? That's true. So if you select 3 random prompts that could be completely unrelated to each other, it might be very easy to perform this task, right? Versus 3 prompts from the same genre and maybe roughly the same plot point but have subtle differences. This could actually be more interesting. So I believe in this case they were all randomly selected. So it basically tells you that maybe there's some word overlap between the story and the prompt, but not much more than that. So in the second eval, the plan and write paper uses this. Given a prompt and 2 stories, so one story generated by model A, one story generated by model B, pick which one is better. So what are some potential issues with this kind of evaluation? Sure, so this is extremely subjective, right? And you probably need to get a large number of judgments to be able to conclude anything, if you can even conclude anything. Another issue is that what if both models are really bad and one is just slightly worse than another model? Then you might get this picture that, oh, this model always wins over this other model. But in reality, the stories from both models are not readable. That's right. So you might consider evaluating the reference text instead of 2 models, right? Given model A and the human written reference, which one is better? The problem with this is that the models are so bad that people would pick the human written text almost all of the time. But again, the evaluation is very, very difficult. Yes? Yeah, so you can do this as well. But then you run into the issues we talked about before with the calibration of the scale and so on. There is a careful way you need to do this if you're going to do it. So that's a good question. Why can't we use the Rouge score to compare? So what do you mean, like between the prompt and the story? Yeah, I mean, I guess on aggregate that could be accurate for the case where there's like random negative, like randomly selected prompts and stories. In the case that he mentioned where there's actually, it's a challenging task because the prompts are all somewhat related, perhaps Rouge score is not the best use case there. Yeah, so in this paper, they have some automatic ways of measuring the relatedness. So you can even look at like embedding similarity of prompt embedding with the story embedding. This seems to correlate as well. Yeah. Okay, so enough about this. I wanted to switch over to some work we have been doing to kind of get around some of these concerns, and this will also have the added property of having humans directly interacting with the output from these systems. So not just like mechanical Turkers are reading the output of the stories and rating them, but like humans are actually receiving the output of the text generation system, and then they're making edits to this output because they want to use this as a writing assistant rather than just as like end evaluators as they have in the past. So in general, this machine in the loop learning is a very interesting and probably increasingly important paradigm in the future, where the point is that a machine is used to improve something that a human is already doing. So on the other hand, there's human in the loop learning, where a human is trying to help the machine improve its predictions. But we might be interested in the opposite, where humans are already doing some activity and we want to try and improve that with the addition of some sort of AI or whatever in the loop. So in this case, you can imagine there are humans who are trying to learn how to write. They might be in a writing class, or they might be trying to become authors and they want to improve their writing craft. And you have a model which can provide suggestions when maybe they get stuck, they have writer's block, or they want to try out some different ideas, but they I don't know, they're stuck for whatever reason, or they don't like what they wrote, so maybe they want to get some feedback on it. There are many possible applications of these kinds of writing assistants, and language models are now powerful enough that they can even suggest, at least for a couple sentences, some things that are relevant to the context and might give a human some new ideas on how to proceed. So this has been worked on before. There have been some prototype systems where you have a language model helping someone who's actually trying to write a story and seeing if it helps or not. I think in this work, Elizabeth Clark's work, they look at using a model to help people come up with catchy advertising slogans. So that seemed to be helpful too. So we are looking at this in the context of story generation. So the way this works is you have some context or prompt or whatever, maybe a partial story that a human has already written, and they send that to some server that, say, we're hosting that has a model on it, a story generation model. That model gets this user query as input and produces some sort of text of the next scene of the story. And that gets sent back to the user. The user can then either choose to completely disregard whatever the model has produced, if it's irrelevant or incoherent, or they can use it completely if it was perfect and it was exactly what they wanted. This never happens. And they could also decide to edit the generated text. Maybe some phrases were good, but the overall coherence was very low, so they just want to use some small phrases that they thought sounded nice or something like this. Or maybe they delete the whole thing, but some of the ideas that were produced in the generated text inspire them to write something else. So there's lots of potential things they could do. So two of my students, Nader and Shufan, worked on this. And this is actually an instance of taking one of these models and deploying it to real world users. And you have all sorts of practical challenges when you deploy a neural network language model to people and have them be able to put in arbitrary queries to this model. We couldn't even anticipate some of them, although in retrospect we probably should have. Eventually we had to make this restricted to users over the age of 18 who had opted into some AI generated feature, because it can produce offensive content and we have no way of controlling. We made a profanity filter, but there's so many ways to generate offensive content without profanity, and this model found all sorts of ways to do that, unfortunately. This site, so basically there's this platform called Storium where if you want to learn how to write stories and you want to improve or whatever, you can make an account on the site and you basically get teamed up with a bunch of other people who are also trying to learn how to write. And each of you get assigned to one character in a story, and you have to write scenes from the perspective of your character. There's these common challenges that form goals, so you don't have to do the work in coming up with the ideas for the scene. You just have to, you have this very constrained task. You have a character has some attributes and properties and other relationships with characters, and you have this goal that you need to address in your scene. So given all of this, write the text of the story. It's very different than here is no prompt at all, go write a story, right? That takes a lot more effort on the part of an author. So here's an example. So this story is called Inspectors, Ghost Hunting for Beginners. And so basically there's a cast of characters. Each of these characters is a different user on the site. They've all been assigned to this team, and they're going to write scenes from the perspective of their character. So this character, Emilia Lopez, also has a bunch of attributes, so she's a lab technician, she has good hearing, she's a coward, but also curious, and so on. So there's one user called the narrator that comes up with the challenges. That's their job. So they're not actually like playing in the game. So here, Emilia is trying to write some text of a scene that addresses this challenge, hit the books. So the hit the books challenge says, you have your personal libraries, the internet, and the public library, time to research what you can about werewolves. So this is the goal of this character at this point in time. It also even gives you some outcomes. So the user can choose to write a scene that will drive the story to either one of these strong or weak outcomes. So I guess here you might start researching about Russian-speaking cats and demons. And then here, in this other outcome, you look like an idiot because you don't find out anything about werewolves, I guess. So you can see that here, Emilia is writing a scene to address this hit the books challenge, and she's using her curiosity attribute to do so. And now, given this, the user wrote the text of the scene. So we can make this into a machine learning task by giving the model the text of the challenge, the attribute that was picked by the user, and asking it to generate the actual text that the user wrote, right? So this is just a little bit more complicated than the writing prompt style story generation task, because there's now different types of context. You have like this attribute, this challenge, all of the other scenes that have been written by all the other characters. So you have a lot of structured context. Okay, so there's like a lot of data in this platform. So the maintainers decided to share all of their data with us, which was great. And as you might imagine, most of the stories are fantasy or science fiction. They're about things like temples or creatures or spacecraft or so on. As an aside, these outputs were produced by running a topic model over the data set. We have not talked about topic models in this class, but if you're ever confronted with a case where you have a large data set and you want to know what kinds of things are being discussed in that data set, your best tool is still a topic model. Without going into the technical details, a topic model will take a large corpus and it will output, and you have to specify how many topics you want to get out of your data set, and it will give you, for each topic, a distribution over the words in your vocabulary that corresponds to that topic. So for this topic here, the words mysterious, temple, and cave had high probability for this topic. It will also give you, for every document in your data set, an assignment over all of the topics. So you can figure out easily, given some story, which of these topics does it belong to. So this technology, the most popular toolkit for it is called Mallet. It was developed by Andrew McCallum's lab here at UMass. It's very easy to use. So if you ever need to do this, you should definitely use topic models and use something like Mallet. It's very straightforward to use. Okay, so with that out of the way, I already told you what we want to do. So basically, we train a model to generate the scenes in the story given all the context. And now we want to put our models on this platform. So someone, some new author can click a button on the platform that says, give me the text of the scene, and they can get the text. So I can actually show you, I hope this works. So we had this test game that we used to develop things. Let me make it bigger. So here there's just two users, me and my PhD student. He decided to make the character Dr. Gregory House. And the scene is, there's some character named Bob who is a doctor and took all of the morphine himself rather than give it to the patients in need. And so bad things happened to him, and I guess my student wrote this entry about what the doctor tried to do. And now I'm playing from the character of Bob, who's the person who took all this morphine. So if I click this, I first have to choose what goal I'm addressing. So there could be multiple goals. It looks like there's only one here. Bob overdosed, which is me, unfortunately. So you can see that there's two outcomes. They're pretty basic. And so I select this. And now I can select one of my attributes as Bob. So I have precise hands. I don't know if that will help me survive this. I have a deep debt. Reveal how your boss is a jerk. Okay, why don't I select this? I don't know how this will help me. Okay, so now I can click this button, which sends this all of this stuff that has already been written in the story, as well as these current choices of what the goal is and what attribute I'm trying to use to address this. And we recently switched this over to using GPT-3 rather than the model that we had trained in the past. So there are some issues with this in terms of relevance. All right, let's see what this says. Doesn't look too great, but maybe I'll make it bigger. Okay, code word. I don't know what that's for. Rebel isn't the boss. Okay, so it had something to do with the boss. Bob began, regrettably did not see the empty eyes of all. This is not even grammatical. Oh, maybe it's like, okay, maybe you can interpret this as the text that someone who is on a lot of morphine would say. Interesting. Okay, I can't evaluate this. It's probably not very good. But so if I thought this was really bad, I could just delete it and write my own thing. If I thought it was not that bad, I could maybe keep something, like maybe I really like this dialogue here, and then I could write some other text in my story, and then I could publish it, and other people could read it. So this thing is available for people to use. And the advantage for us is whenever they interact with the generated text, we collect whatever they did with it, right? So we know if we generated something and the user completely deleted it, and the text that they eventually wrote had no overlap at all with what we generated, that whatever we produced was irrelevant garbage, and the model should never produce that again. So if we are able to collect enough of this kind of data, we can actually fine-tune our models to be better at this writing assistance task. However, that takes a lot of data, and one thing that we probably should have expected in retrospect is that if a new user comes to the site and uses this feature, and the first thing they see is garbage, they're probably not going to keep using it, right? So these are like real-world things that we had a lot of people try when we had an even worse model. Had a lot of people try it out, and they stopped using it after 1 or 2 times because it just didn't produce anything good. And then we had, on the other hand, a bunch of users who were using this feature for every scene that they wrote. So we were like, oh, let's go talk to these users. They're clearly benefiting from this feature. It turned out that they had made some games where they had mandated that all scene entries should be generated by an AI, and regardless of whether it made sense or not. So they were kind of just fascinated by the whole idea and not really using it to write stories. There are very few people that found actual benefit from this task with our first set of models. Okay, so we also asked for some feedback as well. Our first model was just a fine-tuned GPT-2, so we stuck all of the different types of context into the model's input. The only thing, if you have a case like this where you have different types of context, so here we have the text of the challenge, the character's biography, the particular attribute that is being used in the scene. These are all coming from different types of context. So one easy way to help the model distinguish between different types of context is to apply segment embeddings. So as we have position embeddings, we can also learn segment embeddings, which the same embedding gets added to each token of this challenge context. And then once we get to the character part of this context, we add a different embedding that's associated with the character biography tokens and so on. So here we've just learned 4 different segment embeddings, but they serve the purpose of distinguishing these different parts of context. You could also think about using some separator tokens, or if you're using like a GPT-3 model, you might use some markdown formatting to distinguish between the different contexts. But if you can actually train your model, segment embeddings are a pretty easy thing to do. And let's skip over this. So let's say that you receive edits on top of the generated text. So you produce some text, the author decided to delete the whole thing, or they decided to keep 90% of it, but then add some new text. We want to measure for any one of these pairs of like generated text, edited text, what is the difference between those two? And here we should expect that copying is actually a very common behavior, right? The users, whenever something is useful, will likely just copy it over or minimally edit it. So it's a much more constrained evaluation task than like evaluate the generated story with respect to a reference story, right? That is very difficult. Okay, so we basically just use a variant of Rouge, which is called a Rouge L, or Rouge, which is measuring the longest common subsequence. So basically, let's see if we have an example here. Okay, so in this case, all right, yeah. Let's go back here. So we had this generated text here, and let's say the user decided to remove all of the text except this first part, and then generate some random words, which are not found in the generated text. So what we want to measure is this final edited version. What is the longest sequence in this edited version that is also in the generated text, right? And so here we have isn't the boss. So maybe this would be tokenized into, I don't know, 4 tokens. And so we normalize this by the length of the, I forget, either the edited text or the generated text. I don't remember which one. Probably the edited text. So this would be 4 divided by, whatever, 12 tokens that are in this thing, and that's our score. So it tells us what percentage of the edited text comes from the generated text. That's the general idea. Except there's a reason why we're looking at the longest common sequence. So for example, if I had another word, let's see. So I have this word regrettably. Let's say I also use this word here. So here, regrettably, isn't the boss is not a contiguous sequence in the generated text. So I don't get any points for using the word regrettably, even though it occurred in the generated text, because isn't the boss is a much longer sequence. So you're looking specifically at the longest matching sequence, and then the ratio of its length to the length of the generated text. This is also the best metric you can use for summarization as well, this longest. In summarization, you use longest common subsequence. So subsequence actually means non-contiguous sequences are allowed. But here we made sure everything was contiguous. Okay. Yeah.
So suppose someone edits the word the, then the boss is just delete the. Now, isn't boss is not in the original sequence, so it's not even considered.
Yeah.
That's not fair. Should have maybe some point.
That's not fair, but on aggregate, maybe you would expect that. And also, isn't the boss, you would still get points maybe like 2 out of 12 instead of 4 out of 12. So really, you want to have some distinction between the fact that they copied 4 words is very important, right? Even if they deleted 1 word, you want to be able to differentiate that from the case where they copied everything, because that if the model is producing enough good text that the users are using like a lot of it, that's what you want to be aware of. Yeah.
I just had a notice it doesn't let you get suggestions from AI and
Oh yeah, that was for a reason.
Yeah, maybe that's why they're not using it. They see one garbage response and then they can't.
Yeah, but we did this because if we allowed them to just repeatedly generate suggestions, then we run into way too many requests for our servers to handle. That is another thing that we didn't really expect when we started. Like, we knew there would be latency issues, right? It's slow to generate from these models. But the maintainers of this site said they would not allow us to put a model on their platform if it made the users wait more than, I think, 30 seconds to see the generated text, because that's just not a good experience if they're just waiting and for something to be produced. So with that constraint in mind, we had to, carefully choose which models that we use so that we could kind of handle the latency. We had to choose how many users can we deploy this feature to. So we had to do like the staged rollout just to see how much traffic we could handle if everyone was like requesting suggestions at the same time. Eventually it became clear that there were very few actual regular users of this feature, so we could just open it up to the full community. But there are a small subset of users that use it legitimately and have been using it for a year now. And now the model is using GPT-3, so it might become more and more useful eventually. So when using GPT-3 for this task, like, we looked at a very simple example where we have like prompt in all caps, and then story is supposed to tell the model to, at this point, generate a story. But it's a lot trickier if you have something like this, where you have many different types of context. So you might have something like, I don't know, challenge, blah, 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 attribute, right? And you have all these different types of context, and you have no way of training this model. So you need to actually iterate over various formats of prompts to find something that is producing reasonable looking stories. So this is very difficult. Like, we had a master's student who was doing this for like a couple months and seemed to find that like markdown syntax was the best way of getting this model to do things. So like, if you had, I don't know, you could do something like this if it was a sub part of the challenge or something like that. But there are all sorts of weird artifacts that you have to consider if you're using a large language model and just prompting it to do something, versus if you fine tune it, you have full control over what the output format should look like at all times. All right, anyway, so basically we first of all found that top K sampling in this setting was significantly better than nucleus sampling. It's hard to say why that is. It probably is data set specific. But more interestingly is that when we looked at what properties of the generated text were most important, were most likely to lead the user to copying text from the generated story, the most important by far was relevance. So these language models are very likely to generate irrelevant text. If the text is irrelevant, no one is going to use it. If the text is ungrammatical but still relevant, people are likely to use it still, maybe fix it up, but maybe the idea was good if it was relevant, or even if it was incoherent. But if it's irrelevant, then it's essentially useless. So that was the biggest takeaway here. We also looked at how the users modify the generated suggestions. And so we thought maybe they're going to keep like entire blocks of sentences that contain nice scene ideas, but in reality, they basically keep very short phrases, things like cross the security line, an orange sticker across all windows. They don't even respect sentence boundaries sometimes. They just keep random bits of the text that they like. So kind of interesting that it probably depends a lot on the underlying language model as well. So we're looking forward to redoing this analysis with GPT-3. The most common case is that a user completely deletes what the model produces and then writes their own thing. So this is a case where the users want to write a good story. So unless your model-generated text is actually up to their standards, they're not going to use it. So it's very different than this case that we've seen so far in this class where you have a model you evaluated on some held out data in a data set and you get some score. Right here, the evaluation criteria is your model-generated text needs to be useful to someone or they won't use it. We also collected user feedback in interviews, which was very interesting. This was an interesting piece of feedback. I feel like the AI gives me ideas for keeping things going. For example, I was going to say they slay the big golem, but then the machine came up with there was 3 golems, so I had to keep going and rethink the story. I just kept the writing because I liked what I was doing with the cards, and every time the AI changed the story, I just worked with it like a friend, giving me ideas. I think this person needs to learn about some punctuation too. But yeah, I mean, this was like kind of what we wanted, right? They were getting new ideas from the story, and it was the ideas that were inspiring them to keep writing the story. Although it also seems to indicate that the AI was coming up with things that were irrelevant, and then this person just decided to go along with it and write the story that way. This person says, I tried it in one story that is almost dead, which means like all the users were inactive after a while. They didn't like the story. Just to see what the AI would come up with. It was hilarious, bad, and amazing at the same time. This one about like the innuendo and strong language coming through, not suitable for a particular age range. And oftentimes the weirdest part is that it's hard to understand why it would even generate this in the first place. It's not prompted by the context at all. Then we had people who were looking at kind of like meta. They thought that there were many different AIs and started assigning personalities to them. So in a way, this is probably like a good analysis of the different types of outputs. The sweary outsider who keeps getting piercings and tattoos, the reluctant kid who's shy, the convent-educated naive kid who's just taken LSD for the first time. Yeah, so again, like it's very useful in cases where you deploy an actual model to get free-form user feedback about these things. One thing that we found in these interviews was that, just as you suggest, a big problem with the model was it was generating a lot of new characters that never occurred in the story before. Those characters could have occurred in other stories that the model was trained on, but not the one that was actually being conditioning the model on at this point. And they really hated that. Although some of them said, if I needed to produce a new character name, that's actually very difficult for a writer to come up with a name of a new character. So sometimes it was useful, but in most cases it was just not relevant at all. All right, so I think that's it. Any questions?
What if a user took what is written by the AI to just paraphrase the whole thing? So then you get, like, if you're doing longest common sequence, you get like from here score of 0, but then the user has used it.
Yeah.
How do you evaluate that?
Yeah, that's a great point. So what if the user paraphrased things in the generated text, and maybe they paraphrased one sentence and deleted the rest, and we have no way of catching that because our evaluation doesn't account for it. That's definitely happening to some extent. We are not able to measure that with the Rouge score. But one thing we did ask afterwards was, were there cases where you deleted the whole thing, but you somehow were inspired by the ideas in the generated text to write some story? And basically everyone said no. So yeah, who knows? But things can improve. Like this is now there, and other people can submit their own models. So at some point, probably a model will actually prove useful to these authors. But, yeah.
Does it currently work in like finer grain human noise stuff, where like it generates a couple sentences or like maybe a couple words, and then the human says what to do? So
Yeah.
the human goes,
Yeah, so I think this this paper cited here, this thing was called Creative Help, I think, and it looked at the case where the model might generate the next word or the next n words, and then the user can write whatever they want, and then after a while they can ask the model again for a very short generated. So it's kind of like autocomplete in a sense, but for these creative tasks. So that's also something that we considered doing, but that's a little harder in terms of the latency requirement. You don't know how many times the users will demand to use this autocomplete feature for one story. And it's much easier to plan for things when you know, okay, they can only click this button once on this scene, and we can exactly know how long it will take. But yeah, there is work like that as well. All right, let's check YouTube. Okay, great. So we can end early today, finally, and also end for the semester. So that's good too. I will have office hours this week and next week in case you have any issues with your projects or other stuff. And I'm not sure about the TAs. I think they may also have office hours, but they'll post on Piazza if they don't. So good luck on your project. It was a good semester, and wish you all the best on your project reports.